Alright, so let's continue our discussion here. Last time we had figured out a way how to add a couple halogens to the alpha position of a carbonyl under basic conditions. And, maybe you can see where this is going to go here immediately. If we instead switch to acidic conditions, H3O plus and Br2, some kind of acid, it could be H3O plus, although, any acid or Lewis acid or most Lewis acids or Bronsted acids can do this, right? We will end up doing our alpha bromination at a reasonable yield, and it will actually stop after a single addition of the bromine. Okay. The mechanism for this isn't all that different from what you might expect, right? The first thing is, we've got an acid, so use the acid. I'm just going to abbreviate it as H+, right? So we end up doing this. Right, we're setting up, our enol, right? We got some water around. And so this is basically the exact same mechanism that we did in the previous video. We get some green, that's green, that's green, that's green, okay? And then, here we got our buddy bromine. Running out of room. That's okay. And so we end up here. That's there. This is now red. And that's our buddy bromine here. Oops, that should have been green. And then, water will come in and take care of this hydrogen here. I guess I'll just go ahead and finish it up since we're doing it. And that'll give us our product, right? Fantastic. There it is. Cool. And this will stop after a single addition usually, which is useful. We can then go on and do what we need to do with that halogen there. We can maybe do a substitution, although it's not all that great to do substitutions on secondaries and given where it is, right? We can do eliminations. That's probably going to be something that we'll end up talking about quite a bit. We can do an elimination to make an alpha-beta unsaturated ketone, which we will talk about a little bit more further on into this chapter, right? So I'm not going to introduce that here, although it is in the book, and if you look online, they talk about it there. I'll just bring that idea back when we talk about unsaturated alpha-beta unsaturated ketones later, okay? But the point being here is we can now kind of selectively and add a single halogen to the alpha position, and that's great. All right. So let's kind of build off of this idea here and go into one of the major reactions that come out of this chapter, and that's the idea of aldol condensations. Yeah, right. So if we take a aldehyde, or we can even do this with ketones. We'll talk about that in or we'll get to that in just a second. Okay. But if we take an aldehyde or ketone here, so let's start with a better drawing. Okay. So if we have two equivalents of this aldehyde, and let's put in some base and some water, okay? what we will end up forming looks like this. Okay, let's color code this for a second. Let's do that red. Let's do that red. Let's do that green. Let's do that green. Let's do that blue, and let's do that blue. Okay. Now, whoops, sorry about that. No, in reality, right, both of these aldehydes are identical, and so the red, the green, and the blue are, just constructs to help us see what's happening, right? Hopefully that makes sense. But what's going on, right? So our blue alpha carbon there is attacking the carbonyl carbon of the other aldehyde. Well, that shouldn't make too much of a surprise, right? As soon as we've got our alpha hydrogens and we're under basic conditions, right? So we are generating the negative charge here on that alpha position, which is a good nucleophile, right? And we've got a carbonyl, right? So it shouldn't be, let's see, I'm guessing, we'll just use blue here, right? And so we should expect to see this happen here. Maybe not expect to see this happen, but it will happen. But a carbonyl attack, right? A carbonyl attack by a good nucleophile. That's not that unexpected. Right, so we got this, we got this, we got this, we got this here, right? And then the water, right? This picks up a hydrogen from water, right? So we can just color code that red. I'm just going to skip that part. I think you guys understand about protonation at this point, right? So there we go. There's that. This is reversible, though, right? This is reversible. So if I take this, right? Maybe. Will I do this? Okay, I want to erase the whole thing. Good stuff. So this is a reversible reaction. If we take our alcohol over here, right, we are under basic conditions, right? We can do this, right? Which will basically kick us back to this point right here, right? So this is reversible, okay? And ketones are a little bit more susceptible to this reversibility than the aldehydes are, but that's okay. We'll overcome this here pretty soon. But that's I don't want to say that it's not important that it's reversible. It's something to pay attention to, right? Remember, we're kind of doing chemistry on paper. So we can take a couple of liberties, right, so to speak, a couple of liberties, so to speak, when we're doing some chemistry on paper, right? Anyway, right? So what we want to do then, right? This is just formation of an aldol, right? This is just an aldol addition, basically. If we want to do a condensation, what we're going to do is put this under basic conditions, or basic conditions, and then we're going to start to heat it up. Okay, so let's take this exact same idea here. Okay, so AOH, right, and we will heat this up, right? Heat it up. Mechanism starts out the same. Okay, we generate our negative charge, right? Good nucleophile. Attacks, kicks up. The tricky part here, let me see if I can do this while I'm kind of working through things. The tricky part to always remember with these reactions is to count your carbons, okay? Count your carbons, make sure you don't miss something. All right. Whoops, I forgot to, we've got some water around here. That looks good. Okay. And so let's do our protonation. Okay, boom, 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 boom. Nice. Okay, so this is identical to what we just had in the previous example. Okay. Cool. So what happens next? So now, okay, my goodness. Now we blow up my screen and make it awkward. Okay. Now, what's going to happen in this case is we're going to have some hydroxide come in, okay? And it's going to attack that hydrogen that's right there. And this is going to happen, okay? So what does our product look like here? Okay, so let's see, we got our aldehyde, right? There's that. Bond, right? Bond. We don't have an alcohol then anymore. We've got this, right? And we also kicked off some hydroxide and some water along the way, right? And that's it. We have made an alpha-beta unsaturated carbonyl here, right? But really what we've managed to do, if we want to think about it, is we've managed to kind of clip together, right? We've managed to clip together two carbonyl groups, right? Under pretty easy conditions, right? This just takes a base and some heat, right? There's plenty of bases that'll do this. LDA will be useful for us in just a bit, right? LDA can do this, and hydroxide can do this, and ethoxide can do this, and right, there's a couple different methods that we can use, okay? So that's not too bad. And this will work pretty well, right? This will work really well with ketones also, okay? So we can do the exact same idea here, right? If we just transfer everything to ketones now. And now let's put in some LDA, right? Let's put in a little bit of an umphier base, right? We can heat this up, right? And our product, right, is going to look like this, right? Can you guys draw the mechanism to get there? Let's see, how are we doing on time? Okay, so see if you guys can draw the mechanism to get there, and then we can start to think about some other, let's say maybe challenges with this, right? One of the challenges is just having to pay attention to what are the sources of the ketone and the aldehydes that are in here, right? If you've been noticing, all the examples we've been doing so far are symmetric, right? Because we can get a lot of cross reactions, right? So this isn't, these conditions aren't that selective. What I mean is this, right? If I have a mixture of these two ketones, for instance, okay? All right, we've got a number of alpha positions, right, on these different carbonyls that can get deprotonated. Now, truth be told, there is a slight preference, for primary versus secondary versus primary and secondary alpha positions, right? There is that idea, right? But what's happening is these ketones can also start to react with themselves, okay? So remember, we've got a beaker or a flask of this, and we add some acetone into it, and we add some LDA, and we say, boy, I sure hope I get the product I want. You're going to get a giant mixture of stuff, right? So we're going to have to be clever about how we do this reaction, okay? So we have to be careful when we start to have different carbonyls that are in there. And we'll talk about that a little bit more. We'll do that in the next video, okay? But what I want to introduce here, two important ideas in this video. How to do a selective alpha halogenation, and then this idea of aldol additions, right? This is our aldol addition, and then our condensation reactions, okay? And it all plays off of the same idea, right? We're making a reactive alpha position. We're making it into a good nucleophile. It attacks a carbonyl. When we heat it up, it forms an unsaturated alpha-beta carbonyl there, okay? And those are going to be useful for us as we go along also. So there we go. Now we can start to bring together multiple carbonyl groups, and we will see what other fun stuff we can do with it. All right, we'll see you guys in part 3.